I'm going to talk about a potential solution around the topology model to different entities than we talked about yesterday. I'm a representative of the German Federal Waterways and Shipping Administration, which is owning, building and maintaining the German waterways and also the coastal-wide ETS network. So I'm now standing for, let's say, the shore-based user part of it. And by the way, that's your daily intake of the fuel canal, so shrouded in a waterway. So route topology model is an abstract thing, so I would like to give you an overview of what I'm going to present. So what is it? How could it be portrayed? I mean, how could it be made visual to the users? And how do we derive a specific instance of it for the North Sea region, which is the region under consideration at ACCSEAS? And of course, I would like to present some conclusions. Let's start with what it is. It's a model, an abstract thing, which represents voyage and traffic relations. So it's in the mathematical domain, the abstract domain, the data domain, if you will. And by introducing this thing, we apply a long-standing, well-developed theory of mathematics, which is called graph theory. And this was brought to our attention at a user forum, which we had in Oslo last year. And I'm also representing in this presentation the facts and findings we had in the working group in the ACCSEAS project as of today, up to now. So this was the starting point, and it's very simple how it's constructed. It has two domains which are intertwined, so-called nodes and legs. A node is something where you connect to, and a leg is a line between the two nodes. And the model is just built by using these two entities, by putting them together somehow. And the two are connected by reference, and this is shown in this diagram. And I will continue in this building on this very simple concept. This next slide. Oops. So what is a node? We started with the IMO understanding of a very fundamental node, which is called a waypoint. So what we want to do is to tie it into IMO's thinking of the thing. So waypoint is where a ship needs to pass by. And there are certainly different varieties of those waypoints, if you will. One of which we call node junction, node bend, and a port. Of course, that's the thing we want to arrive at eventually. So, again, this is an abstract thing, so there is a generic route topology model which is described in abstract terms, and it is by default valid globally. So the idea is that this could be in contribution to the e-navigation strategy of IMO, in particular to the Common Maritime Data Structure, which is envisaged by IMO and which is supposed to be built based on the IHO S100 framework. So generic means that everybody could use this eventually as soon as it's been defined. And of course there may be many instances of the same thing for each sea area under consideration, for instance the North Sea region. And of course various applications built on this as soon as it's defined. So that's the theory. Now let's turn into how it's being portrayed, and that's the jump into the application domain. You learned yesterday user-driven design, so I used the architecture picture of IMO to depict where now we are talking about in terms of presentation of this model, was a result of this model to the users. And you see the two circles, shipboard users, shore-based users, and I will talk about both of them. And of course, different users need different ways of portrayal, and different applications are operating there. In the process of discussing this within the ACCSEAS project, we identified three different modes, if you will, how to portray these abstract things. First thing would be an ENC actus layer mode. Second thing would be something we called tentatively London tube map mode. And the last thing would be a head-up display augmented reality mode. And within the ACCSEAS partnership, several people are working on the different aspects of it. Let's turn towards the ENC actus layer mode, because that appears to be the one which is the closest to where we come from, chart-based, chart-oriented. It shows nodes, legs, and routes, etc. in a true topographical context, so like a chart does. So it could be used if you use a certified ENC, for instance, also for navigational purposes. And it's at the meeting point between tactical and strategic needs of a vessel's voyage. Because it's based on the chart, you can have tactical insights into this and also strategic ones regarding voyage planning, for instance. And this is how it could look like. This is an example we derived, an initial version of such a model for the North Sea region. You see the AS footage, that's a colored thing. The redder, the more AS messages and the more vessels. And of course you see the lines, which is just exploiting this density thing to identify existing routes. And if you take away the AS footage, this is how it looks like. In the initial version you see through gaps and holes. We need to fill this in during the remainder of the project. But this is how it could look like on a large scale. If you zoom in, of course, the details come out. Here's another example. The past ones was for past and present situation. Now this takes us into a future outlook, introducing also the windmills and other marine spatial planning features, which are identified by the, what is this, brownish or orange color. And thereby you can also have a planning tool on the chart base for the future. The London Tube map goes a totally different direction, as you may know from traveling in cities with tubes and public transportation. It reduces the topology thing to the minimum, thereby introducing only the essence. Where are the lines operating? Where are the stations? Where are the junctions and so forth? So it's principle to deliberately ignore the true topology in favor of, let's say, just in our maritime case, shipping lanes. Where are they and how do they connect? So this is certainly a tool by which you don't navigate, but by which you can do strategic planning. And it could be used, of course, on the shipboard side for individual voyage planning. Which line do I need to use to get from A to B? And of course, and that's the interest of my administration, certainly traffic organization as a whole, we want to deconflict traffic, and we need to do so because the density is high and the conflicts are there. Where are all the vessels? First question. And second question, when will vessels meet where? So we have a lot of practice in this regard. For instance, the Kiel Canal is operated by such a grid, and now the ACCSEAS project made a case that similar schemes may be necessary not only in confined canals, but maybe beyond in the North Sea area. So Traffic Organization Service is a well-established part of the vessel traffic services domain, and that's the point under consideration here, and certainly the London Tube map would help in this regard. And that is how it could look like. As you can see, it resembles some major fairways. We call this motorways of the seas, or the EU calls this this way. And if you have this level, then it looks like this. That's an example from the German coast. But there could be additional levels defined. Road of the sea, we have as a proposal, or small craft shipping lanes. If you zoom into this, more and more of these kind of portrayal will be visible. What you see is the essential features of this traffic grid, if you will. Now, the last mode of portrayal is a head-up display of augmented reality, and the idea is that you have this on board a vessel, and that's maybe the most futuristic part of the portrayal modes. In the future, you can envisage maybe a situation where you see more detail augmented on the windscreen of a vessel, such as this. And what you see in here is this little dotted line, for instance, would project your route into well, what you see. And of course, the red square would point you to an object of interest, maybe a ship coming by or ferry crossing or something. And it could be developed in more. If there's junctions, for instance, then there would be a junction displayed. If there's areas of interest, it could be presented as well, based on the model we have lying in some database at the back of it. Well, and those modes do not exclude each other, quite the contrary, they can coexist with each other. So for the different users we can foresee such a situation where you have, for the shipboard side, all of those three operating, maybe not simultaneously, but at different times for different tasks, but could be present in the future shipboard environment. And the same holds true for different tasks for the shore side. Obviously the head-up displays augmented mode certainly has some specialty for the shipboard side. And this is fulfilling the scalability requirement by IMO in their e-navigation strategy. Another thing is it would be extremely helpful to talk the same language, and therefore IMO has said we want to harmonize a lot of data stuff in the e-navigation domain. And that's another thing we need to look into, that all of those FOD-rail nodes tap into the same data model and that same data when it comes to instances. And IMO has called this a common maritime data structure. And within that common maritime data structure, it is envisaged that we have a route topology model developed. Now, how do we derive such a model? 3 steps. First of all, you need to determine the point of time in time where we look at past or present and future. And of course, different sources are needed for these different points in time. Secondly, you need to have a generic model to build on that provides you with theory. And third step is turn towards the region under consideration, in our case north of the region, and apply the model. Well, determine point in time sounds simple, but it has its intricacies. First of all, for instance, if you choose past and present traffic situation, then of course you can make use of the AS track data. That's empirical data. It shows you where the ships actually travel, but it doesn't show you where they could travel. That's something you need to add. Then of course the future projection you need to take into account marine spatial planning. And that was one of the starting points for this consideration. So we look into the future, in particular in offshore installations and particular sensitive sea areas, and take those into account and saying, okay, that's constrained to the margin where a vessel can operate. And then, of course, we have certain influences which have different degrees of binding strength. We have, for instance, the topography, where there's water and where there's land. Of course, on land you can't travel, so that excludes effectively routing. And then we have routing measures, such as TSS, which are defined by IMO and are well defined and very well protected, so you need to take those into account as well. And of course, we have existing no-go areas. Well, then we look into how to derive the generic model. And this is a result of some research we did in regard to, has somebody worked on something already? Yes, and the answer is quite a few people have worked already, and it's not a new thing, it's quite well established in some regards. So for instance, to start with IMO resolution, guidelines for voyage planning, that's a well established thing and of course needs to be taken into account. But then, look at a circular which was released some years ago on the AS application-specific messages, and there is a very well-established IMO definition for route data transmission via the ASM. And we have, as a sister document, an IMO performance standard and an IC spec, freshly released this year or last year, on the portrayal of such routes. So it's defined already for the shipboard side, at least. Then we have an EU directive, which is called INSPIRE, which has also done some work on transport networks. That's a module in it, and this is binding law in the Union. Maybe not that draft document, I shall show in a moment, but it's a legal thing. And then we have the concept of the motorways of the seas, which ties into this. I showed this already. And last but not least, we have an ongoing EU project, which is called Mona Lisa 2, where we have a lot of this work done from a different perspective, but maybe it ties into this very well. So my point is, take this in advance, we need to harmonize these different strands somehow for the best of all the different uses. So let's have a look into this. That is AS application-specific messages, and you see those 4 pages contain data definitions besides an encoding. please listen carefully. I'm not saying that we need to transmit or should transmit the route topology model by AIS. What I have said is the data definitions therein need to be used. So I did two things in creating this document: data modeling and encoding. The data model could be used by any transportation means, such as maritime cloud. But it could as well be used by AIS right now, it's there. So both is true. I have not said, please quote me correctly if you quote me, that we should use AIS for that purpose. I know there's a big discussion about capacity and stuff. That's not what I'm saying. I'm saying we need to look at this document and extract the data model and transfer to a, let's say, a little bit more generic plane. But it's there, and it's valid. Next one is the IC spec based on an IMO performance standard, and it's valid as well. And here you see a portrayal mode for the ENC domain, for the ENC board, how you show such a route with waypoints and even estimated times and distances along your voyage and so forth. Very interesting stuff. It's valid since half a year ago. Inspire. Look at this picture. I lifted it out of the document. That's slightly inland biased. So the Kiel Canal we could easily cover, for instance, or the Elbe estuary. But of course the sea part needs to be a little bit more populated and needs to be brought into simplifiable thinking. This is informed by land surveyors. And they are looking for people who are doing this kind of, let's say, maritime extension and verifies this from maritime perspective. And there may be a cooperation in the future, maybe ACCSEAS or beyond, with those folks. And what you see on the right-hand side is an UML model. You can't read it, but I can show you the documents. But it's well developed, so we have something in store there also. Then the motorways of the seas concept. This is 10T documents. Might be interesting for the Commission to note that there's a lot of intertwining with logistic chains. What we now could add by such a route topology model is, instead of the question marks, you see the motorways of the seas number 21, or this picture which is slightly flawed. We could add the true picture by our work. So this, and thereby have a full recognition of how the road or land traffic connects over sea to and fro. Mona Lisa, last but not least, we saw a nice presentation in January on the ILR DMA conference, e-navigation underway. And to your right-hand side, you see the list of data objects they define for a data exchange in regard to routes. So that may provide another source for data modeling. And of course, these sources are available and need to be harmonized. Now let's turn to the last step, how to derive a instance of it. What you see on the left-hand side is different stages of the AIS footage being interpreted. And of course, these pictures you saw, they end up in a database, which is constructed very simply by a table of legs and a table of nodes. What you start with a table of nodes, and then, of course, a table of legs is constructed by this. That is for the past expression situation. You take the AIS footage, and of course you have the planning data, in this case windmill city, offshore windmill city of Germany, fully legally described in this shipping lane grid, and you need to take that into account when planning for the future. And you arrive at a database where you have all your nodes and legs described. Well, conclusions. So what I said already, we have a lot of stuff to work on, and the task would be internationally to harmonize the different contributions, some of which have already quite high standing. So the right place to do so would be, as part of the IMO envisaged common maritime data structure, a section, a domain, or however you would like to call it, which would be the generic route topology model definition. This could or should be done by something which I would like to call the International CMDS Roundtable. IMO has given it a name. It's called Harmonization Group on Data Modeling. It's not active yet, but it may be invoked in due course. And of course, IMO has ruled that it should be transformed into an S100 based something. And that is organized in registers. These registers, with some amendments, which some people deem necessary, are shown on the right-hand side. So they have features, they have portrayals, they have products and stuff. That would be a presentation in itself. So the proposal would be, let's start with this kind of work and transform all the material we have in a harmonized manner into the common maritime data structure by using S100 structure, and thereby doing harmonization. As soon as everybody sits around the table, then all the views are being brought to the fore. Well, what are the applications? That's a long list we discovered with user interaction in the Oslo view. The view is ACCSEAS means to get in contact with stakeholders. So of course we recognize that the RTM would support the maritime service portfolios. There was a lot of talk of it yesterday in the opening presentation. Then of course it lends itself for transport and traffic pattern analysis by policymakers. Then RTM supports traffic planning and management in strategic and tactical terms when it comes to runtime. And of course it supports transport management of vessels' voyages for transport by employing an improved route and voyage planning on the basis of RTM, both regarding initial, i.e. pre-trip, and en route planning or route planning. That may support in the future new ways to do traffic organization, the TOS service, with a better intake of just-in-time arrival processes, such as scheduled time of arrival concepts or time slots or whatever concepts may be built upon this. For these ends, you need to have a very precise database on the routes. And of course, what we saw yesterday is the maritime information dissemination could be tailored to routes as well. So we could tailor for specific needs on those routes for different user groups. And of course, by simply doing such a model for a sea area, everybody around the table, when coming up with an instance, by doing this, agrees to this route. So that's a major catalyst, if you will, for arriving from different angles of perspective at the same conclusion in a way of agreement. So that in itself is an effect which should not be underrated. And that is of course something we should end up eventually in the North Sea region with, not in the ACCSEAS project, but maybe beyond, and that's tying into something Peter is investigating with the work package 8. Well, next one would be improved risk assessments. The work of the Danish Maritime Authority, shown in this icon, could be tied to the routes as well, so we can have a numerical model on this tied to the route topology model. And of course, that was discussed at the last conference. We could protect in the North region the shipping interest better by maybe an improved traffic separation scheme grid in the future via the usual IMO procedures to protect interests of shipping against, let's say, usage of maritime spatial planning. So that is a well-protected thing and could be developed using the route topology model. And of course we could do, based on this better knowledge of where ships could go and where they go, do better cost-benefit analysis in whatever regard. Right, so next steps within the ACCSEAS project, 1 year more or less. We would compile the above RTM story, if you will, into an ACCSEAS description on route topology model, so you can read it, and it will be a little bit more elaborate. So that's a document we have under work already, and the story I just presented will be the core of the document. We would also like to create an initial North Sea region route topology model database, so we are going to extract the nodes and legs from the various sources, and of course includes the future 2020 plus situation if known. And of course we would continue our work in regard to the portrayal mode. modes. The ENC mode is well established. Now we need to turn towards the London tube map and maybe to the head-up display depending on time available. So that's the plan for the remainder of this project, and the hopes are high that we have a good result, and of course this is done by the ACCSEAS partnership in collaboration and not just by me alone. Thank you very much indeed.
Well, yeah, Henrik, a cracking presentation. Are there any burning questions before we go on to the next service? Good.
Thanks a lot. That was excellent presentation. Thank you for the comment about the model SFC. That's easy to take since it's in our unit. So the colleague next door is responsible for the policy development. So if you have something, just pass a little line and we'll see what to put there. About the data model that you mentioned, did you in your work look also the existing or the ongoing works on the reporting formalities, nationals in the window? Because there we are defining at the moment the data model for the nationals in the windows. And of course, when that discussion was done, the start was with the IMO data model, but then we saw also that that's not covering all the elements like cargo related and some other elements. So there has been also discussion on the World Customs Organization data model as well as the ISO data model for the XML level messages. So just was this considered?
Well, in regard to the second question you raised, was this considered in regard to the single window? No, not yet. So the reason is simply because we have tight time constraints in the project, and we started to get, let's say, to the core of what has been worked on in regards to routes first. Of course, I see the connection because we have something like a node port where this ties into, and of course there are certain reporting points along the route. So I see as a connection, but since we started from scratch and doing this work over, let's say, one year more or less so far, has reached now. So that is where we put our focus for the time being. Having said this, we are in contact with commission bodies like, let's say, the Inspire folks at GRC and in ISPRA, and so they would be happy to find a project, maybe this one or another one, to exchange views. And I understand that Inspire has a very broad view, one of which is the module TN. There may be other outlooks. So I guess this question will pop up naturally in the future, most likely only after the ACCSEAS project. I do ask you to understand that we cannot cover every aspect, but your point's well taken. It needs to be done later on.
Just very quickly, there will be the data model should be validated in May. So that's 160 data.
Thank you.
Don't go away. Don't go away. I'll take one last question. Edward.
Thank you. Accepting this as a test bed and therefore trying to demonstrate potential and investigating what potential is, but assuming that it is successful in doing that and this becomes something that is routine and live, who do you expect to own the route topology model, to maintain it, to regulate it, and what responsibility would that group take for assuring the safety of those particular routes that are defined within it?
I understand you are from the UK Hydrographic Office.
Doesn't show, does it?
That more or less points into the direction. Well, so far, e-navigation, and this thing could be part of it, is operated and governed by IMO. So the idea would be that the Common Maritime Data Structure is, of course, an IMO baby. In this regard, IALA certainly has a role in putting in the VTS part. IHO, hydrographic offices, UK, I'm talking to BSH in Germany as well, certainly will have a role when it comes to S100 domains, and that route we would like to go with a product specification. I mean, that's at least the outcome recommendation out of this project. And by doing this, to answer your question precisely, the data modeling would be kept ideally in the S100 framework. That means that we would use IHO's registry until further notice in the future. And we would undergo all the requirements by S99, so submitting organization and so forth. And thereby harmonization would be guaranteed. The ownership of the whole of the model eventually would reside with IMO, IHO, IOLA, as soon as IOLA may be an intergovernmental organization, then we have the three of them put together. And so that is our idea in this regard, or that would be the recommendation. Regarding the instances, such as the North region model, a body needs to be found which is in a position to do so for the region. Maybe OSPA may be the right place, because it's an intergovernmental thing again. I don't know. It needs to be investigated.
Yeah, thank you very much indeed. We'll let Matt set up now. For an excellent presentation, there will of course be a question and answer session a bit later on. So, Jan Hendrik, thank you very much.